Example 8 wants us to graph this log equation. It says for all graphs, we're using this right here. So you can see that all in the graph. This is my x min and max, which you can see we are going from an x min of -5 to an x max of 25. And then a y min and max of -4 to 4, because here's my y min of -4 to my y max of 4. My x scale is scales by 5, and my y scale is scales by 1. So let's put this into our graphing calculator. We have log of x minus 2, closure parentheses, minus 1. And we can graph this in our graphing calculator because it is a common log, right? So until next lesson, the only two kind of logs we can graph are common logs and natural logs. So let's go into our window and change it to match. We've got -5 to 25 with a scale of 5, -4 to 4 with a scale of 1, and then we'll hit graph. Okay, now let's just go ahead and grab our points real quick. And then I want to come back and talk about this graph that we see on our graphing calculator. So I'm going to go second table to get some ordered pairs here. And there we go. That looks better. Oh, that was a little off. So I had 2 parentheses here. Make sure you didn't do that. When you hit log, it already opens up the parenthesis. So we don't need another one. So log opens up the parenthesis x minus 2 and then close it minus 1. Okay, that's what our graph should look like. Okay, much better. So now I'm going to go into my table and plot any points that I can. Here I have 3, -1. So 1, 2, 3, -1. And I'm gonna put that right here. 3, -1. See if we can find any other whole numbers. We have 12, 0. So 1, 2, 0. And can we fit any others going to 25? No. Okay, so that's all we can fit. So we do have a vertical asymptote when we have logs. And right here, this is where my vertical asymptote is. Where that first error happens is where your vertical asymptote is. So here at x equals 2. And then I'm going to just make a note here. First error. So here's what I want to talk about on that graph here. On your graph, this almost looks more like a square root function because it looks like it starts right here and then goes infinitely in one direction. But this is actually going down forever too. It's just it can't get too close to this vertical asymptote without actually touching it or crossing it. So it just kind of stops when it's about to get too close. So we need to realize that this is going to go down forever. So this is going to arrow down, and then this will go something like that. So that is my graph right there. Example 9 is going to be one similar to one you see in my math lab. Don't overcomplicate this. This says write the inverse of y equals 5 to the x in log form. So if I rewrite this as my inverse, let's kind of look at the pattern here. If I go back to the very first page of this lesson, I had 2 to the x power, and what was its inverse? Its inverse was log base 2 of x. So same exact pattern here. If this is 5 to the x power, its inverse would be log base 5 to the x. Okay, as simple as that. Base of 5, base of 5. So part B, we need to graph y equals 5 to the x and its inverse and discuss their symmetry. Okay, so let's get some values here. Graph this in our calculator. We have 5 to the x. Here's my graph. Now this graph is actually fine, but I'm actually going to go to a zoom 6. Since that's what my graph is here, that's a standard. So here is my graph. If I go to my table, what values here can we fit? Those are all fractions. I can do 0, 1, 1, 5, and then 225 is nowhere close to my graph. So only these 2 points. 0, 1, and 1, 5. I'm going to go ahead and plot those. Okay. And we're going to remember that we have a horizontal asymptote right here. This is y equals 5 to the x power. And horizontal asymptote at y equals 0. Now for my inverse of y equals log base 5 of x. I'm just going to switch these. So 0, 1 over here in my y, 1, 5 in my x. So I'm going to plot these. And this one we need to remember has a vertical asymptote right here at x equals 0. So this one is not going to cross the y-axis. If we want to, for visual purposes, we can put in our line of symmetry, which brings me to the next point. Discuss the symmetry of this graph, and that is that graphs are symmetric with respect to the line y equals x. And label all of that in my graph. Now, when you're doing this in MyMathBot, it's going to be way more simple than this. You do need to be able to find the inverse. So again, it's just a log with the same base as your exponential base. But when you go to graph, you need to hover over the tools. You'll see one tool that says exponential tool. So click on that. And all you need to do is go in there and change the base to a 5. I think it starts with a base of E. So go in there and change the base to a 5, and then it's done. Same thing here. Then you need to hover over your graphing tools. One of them will say a log tool. Click on the log tool, click anywhere in your graph, and then change the base from E to whatever base you have. In this case, it would be 5.